Hello friends, welcome to the C programming. Today we are going to talk about Unit 1, that is Introduction to Programming. Here are the contents of Unit 1. So we will be talking about scope of the programming, categories of programming languages, programming design practices, then problem solving using algorithms and flowcharts, and performance analysis and measurements. Let's talk about scope of programming. To know this scope of programming, we need to know what is a program. So, a computer is a tool for solving problems with a data. A program is a sequence of instructions that tell a computer how to do a task. You can think of it like a recipe that tells you how to make a peanut butter sandwich. In this model, you are the computer, making a sandwich is the task, and the recipe is the program that tells you how to execute the task. You can try performing this activity. Of course, it's an easy task for a person, but computers are dumb. A computer will only do what you tell it to do. This might make programming frustrating at all, but it's relieving in a way if you do everything right. You know exactly what the computer is going to do because you told it. So, what's a program? This will give you an idea. So, we encounter a problem, then we think on it how to solve that problem. Now, that will be in the form of human understandable form. So, we frame some instructions to solve that problem. For a machine, we have to write a program in such a way that machine can understand. And with the help of machine, we can solve the problem. So the program look like this, that a problem is written in the form of human readable instructions, then that needs to be converted in machine understandable programming language, and then machines will help you to solve the problem. Next, what is a programming language? So next question we should ask is, why should we create computer programs? So what it makes computer programming useful or pointless? What are the goals, common problems and solutions related to the computer programming? So there are some basic goals of computer programming that when you're planning to create computer program, you should ensure few things like your program should fulfill the need it is addressing. That means you should clearly understand what is a problem. Then you should also seek the proper solution, and you should also ensure that implementation of that solution effectively done using computer programming. Then you should also ensure that people should easily understand the program that you're writing. Your program should also be able to get fixed or improvements later if needed. Computer programming enhances problem solving using logic. It is also helpful in developing a high understanding of principles of programming. It also demonstrates the basic concepts and software applications, and also it recognizes ethical working codes. Now let's talk about characteristics of a good program. So a program need to possess these characteristics, like it needs to be portable, it needs to be efficient, effective, reliable, user friendly, and self-documenting most of the time. So, what does it mean by portable? So, being portable means the program or software should run on all computers of same type. By same type, we mean a software developed for a personal computers should run on all PCs, or a software for written tablets should run on all tablets having the right specifications. It needs to be efficient. Efficient means a software that does the assigned task quickly is said to be efficient. Code optimization and memory optimizations are some of the ways of raising program efficiently. Then, the next characteristics is being effective. The software should assist in solving the problem at hand. A software that is said to be effective. Then it needs to be reliable, means program should give the same output every time the same set of input is given. You being user friendly means program interface and the clickable links and icons etc. should be user friendly. And lastly, self-documenting means any program or software whose identifier names, module names, etc. can be described itself due to use of explicit names. So these are all different characteristics of good program. Let's talk about programming domains. So there are basically four programming domains that can be categorized. They are scientific applications, business applications, artificial intelligence, and web software. Now, the scientific applications are the applications where the programs which requires high amount of numerical data and which requires complex algorithms to analyze that data. Such applications can be categorized as scientific applications. Then there are some business applications where commercial data processing is done. Like if we are performing the online. Now let's talk about programming domains. So there are broadly four different programming domains that are scientific applications, business applications, artificial intelligence, and the web softwares. So scientific applications are the applications where mostly numerical oriented data is used to analyze in or with the help of programs and with the help of computer applications. Business applications are like commercial applications where the data processing is done for the analysis of some strategic information. In artificial intelligence, it is like emulating human style reasoning on a computer. So we write a computer programs which act as if it is acted by a human. And the web software are the languages where web softwares are the languages used to design the web pages. So currently there are HTML, PHP are the prominent languages which are used to design the web software of the applications. Next, let's talk about categories of programming languages. So broadly, there are two categories, that is low level languages and high level languages. Then in low level languages, we can think of two more subtypes, that is machine level language and assembly level language. We can look at this depiction and can conclude that where this low level and high level languages stands. So for example, if you have a hardware, to deal with the hardware you require a machine language, and that's why it is called as low level language. So machine level language is made or is written in the form of binary numerical system, that is in the form of zeros and ones. The assembly language stands above the machine language, which is also a low level language, but there are some human readable instructions that programmer can understand and can use to deal with the hardware. Above assembly language, there resides high level languages, which includes the high level languages like C, C++, Pascal, and even more sophisticated languages like Java, PHP, etc. So let's talk about these categories of programming languages in detail. So let's talk about low level language. And the first low level language is machine level language. The machine level language is a language that consists of a set of instructions that are in the form of zeros and ones, that is called as binary form. As we know that computers can understand only machine instructions which are in binary digits, that is zeros and ones. So the instructions given to the computers can be only in binary codes. Creating a program in machine level language is a very difficult task as it is not easy for programmers to write the program in machine instructions. It is also error prone as it is not easy to understand and its maintenance is also very high. A machine level language is not portable as each computer has its own machine instructions. So, if we write a program in one computer, will no longer be valid in another computer. So there are some different examples of the processors which are using this machine level languages. So the different processor architecture uses this machine cores. For example, PowerPC processor, which contains RISC architecture, that is reduced instruction set computers, which requires different code than the other processor like Intel x86 family, which has a CISC architecture, that is complex instruction set computer. So for different architecture of the computers or the processors, we require different type of machine code. The next language that we are going to discuss is the assembly level language, which is still from the category low level language. The assembly language contains some human readable commands such as move, add, sub, that is subtraction, etc. The problems which we were facing in machine level language are reduced to some extent by using an extended form of machine level language known as assembly language. Since assembly language instructions are written in English words like move, add, subtraction, multiplication, etc., so it is easy to write and understand. As we know that computers can only understand the machine level instructions, so we require a translator that will convert the assembly code into the machine code. The translator used for the translating code is called as assembler. The assembly language code is not portable because the data is stored in a computer registers and computers have to know the different set of registers. This set of registers are specific to particular type of computers. So the assembly code is not faster than machine code because the assembly language comes above the machine language in the hierarchy. So it means that assembly language has some abstraction from the hardware while machine language has zero abstraction. We can go back to this PPT slide and you can just see that if assembly language would like to deal with the hardware, it first needs to be converted into machine language and then only the it will be able to deal with the hardware. And that's why machine level assembly level language will be bit slower than machine level language. Now let's talk about the differences between machine level language and the assembly language. Now, as we already saw, the differences being abstraction or being faster or requires translator. So, based on these criteria, we are going to discuss the difference between these two low level languages. So, you can see machine level language comes at the lowest level in a hierarchy. So, it has zero abstraction level from the hardware. That means hardware can be directly interfaced with the help of machine level language. But the assembly language comes above the machine level language So that means we require a translation, and that means it has a less abstraction level from the hardware. So it cannot directly deal with the hardware because it is abstracted from the hardware. Then a machine level language cannot be easily understood by humans because it is in the form of binary digits, that is zeros and ones, and it is hard for humans to remember each and every instructions in the form of numerical codes. But in assembly level language it is easy to read, write and maintain also, because it uses the common English words like add two numbers or subtract two numbers, etc. Then the machine level language is written in binary digits, that is, in the form of zeros and ones. But the assembly level language, as I just said, is written in a simple English language so that we can easily understand. Then, machine level language does not require any translator as machine code directly executed by the computer, because machine level language just sits above the hardware. There requires no any translation, because whatever hardware understand or whatever the implementation of hardware is same used in machine language, that is in machine code we are using zeros and ones, and even the hardware or the ICs or their connections all are using this logic of zeros and ones, so it does not require any translator in between. But assembly level language requires a translator so that it can convert the assembly code into the machine code. Then, this machine level languages are called as first generation programming languages, and assembly level language are called as second generation programming language, as machine level language came first and the assembly level language came later. Then let's talk about high level languages. So, high level languages are the programming languages that are more needs that are more understandable by the programmer, which allows programmer to write the programs in the independent or particular type of computer. Now let's talk about high level programming languages. In computer science, high level programming language is a programming language with strong abstraction from the details of the computer hardware. In contrast to low level programming languages, it may use natural language elements and will be easier to use or may automate significant areas of computing system, making the process of developing a program simpler and more understandable than when using low level languages. The amount of abstraction provided here is really high, and that's why we call it as high level programming languages. The first high level programming language designed for computer was Plan Calcul. It was created by Konrad Zuse. However, it was not implemented in his time, and his original contribution were largely isolated from other developments due to World War II. So the high level programming languages are considered high because they are more closer to human language than machine level language. So here the instructions will be more like English language, which is easy to understand, easy to write, and easy to explain as well. But because we have high level of abstraction, again, we require a translator which will convert this language into the machine code so that it can be executed on a computer hardware. So, we require a compiler, which is a specific tool used in high level programming languages. So, compiler is required to translate this high level language programming into the low level language programming. Now, let's talk about advantages of a high level programming language. It can be clearly understood that since high level programming languages are more closer to human and their language, it is going to be easy to deal with them. So the high level language is easy to read, write, and maintain as it is written in English like words. And second advantage is that they are designed to overcome the limitation of low level languages, that is portability. So we have discussed that how this low level languages, that is machine level language and assembly level language, are not portable because they are the device specific or hardware specific language. So high level languages eliminates this problem and by being portable. That means if I write a program on my computer machine using high level language, the same program can be executed in some other machine because this is written in high level language and it is portable. So such languages are not machine dependent, but that's why they're called as machine independent. So we can summarize that portability means being machine independent. So these were the advantages of using high level programming languages. Now let's talk about this difference between low level programming languages and high level programming languages. Since we had already discussed that what are the low level programming languages and what are high level programming languages, we can easily understand the difference between them. So you see, in low level language, it the program written are machine friendly. So we call it as machine friendly language because computer understand the machine language which is used or which is represented in the form of zeros and ones. But in case of high level languages, it is user friendly or the human friendly language as this language is written in simple English words which can be easily understood by humans. The low level languages takes more time to execute, but the high level language executes at faster pace because nowadays these high level programming languages are becoming more sophisticated in terms of memory management. Then low level language requires the assembler to convert the assembly code into the machine code. High level languages also require such translator, which is called as compiler, to convert the high level language instructions into the machine code. So the difference here is that here we require a translator that converts assembly language into the machine code. Here we require a compiler which converts high level programming language instructions into a machine code. Then, in low level languages, machine code cannot run on all machines, so it is not a portable language. But we just saw that how an high level program is portable, that is, the program written in high level language can run on all the platform, so it is called as portable language. Now, low level languages are memory efficient and high level languages are less memory efficient because they require high amount of memory to store them into the computer system. Then in low level languages debugging and maintenance are not easier, but in high level languages there are tools which are given to debug the programs. So debugging and maintenance are easier in high level programming languages. Next, what are the different programming design practices? So, program design practices means what are different steps or what are different approaches that you take to design your program. So, there are two program design practices. One is top down and the other one is the bottom up. Now, in case of top down and the bottom up programming, these are based on the strategies of developing a computer program. So it is you who is going to decide that which strategy you're going to use. So to know what is the top down and the bottom up approaches, let's talk about them in detail. So in top down programming, it starts by implementing the most general module first, and it works towards implementing the modules which are specific to the functionality. In case of bottom up programming, it implements the modules that provide specific functionality first, and then it integrates them by implementing the more general modules. So most programs are developed using combination of these strategies. That means it is not necessary that you should have any one of this strategy. So you can have mix of both the strategies. That is, you can design program using top down approach. At the same time, you can also use bottom up approach to design your computer program. Both strategies are based on incremental development. So the process of building your program is done piece by piece. So here we can think of this top-down approach. Here is an example. This example is regarding designing a payroll processing system. So here the problem is broken down into the smaller units or called as modules, and they are further broken down into even smaller units. Each unit will be called as a module, and each module is a self-sufficient unit that has everything necessary to perform that particular task. So in this top-down approach, let's think about that. We have to design a payroll processing system. So you can think of some major task or some major functionality that a payroll processing system does. For example, getting the employee data into the system, then calculating the net pay, and then printing the pay slip. Now, to calculate the net pay, you may require further tasks like you may require calculate gross pay, calculating the deductions, and updating the employee record, maybe based on their attendance, etc. Then, while printing payslip, you may require data from different modules like get employee record, get the net pay of the details, and get the leave records. So here, if we are talking about top-down approach, we will first think of this in a broad that what is a payroll processing system needs to be. Then we'll think of the details that needed to be implemented, and even we can go further breaking down of those tasks. So this approach is called as the top-down approach. The next approach is bottom-up approach. In bottom-up approach, you first think of the specific functionality, and then you go on adding those functionalities in some general modules, and finally you come up with a complete system or an application. So here in this case, in this example, you can think of making a calculator as a system or as an application. So we may start with this particular functionalities, like you may require a program which may calculate the square root, or which may calculate the algorithmic value, or which may perform this logical NOT operations, which may perform comparison of two values, etc., or it may perform logical and it the other program may perform addition, the other program you may require for subtraction, the different programs you may require for multiplication, division, and all. So now think of that you have designed all these programs separately. Now you can combine these programs if they have something in common. So for example, these programs like addition, subtraction, multiplication, division can be summarized in the module like multiple input operation, so which requires multiple operands to perform this operation. You can perform this you can combine these two programs like comparison programming, logical and of program, in saying let's say two input operation. So that means here you require to perform this you require at least two inputs. So for comparison also you require two inputs so that you will be able to compare between the values. In case of logical and also if you want to perform ANDing of the values, you require at least two inputs. So you can categorize them at this level. That means this is what the generalization of these functionalities into general module. Similarly, we have generalized the functionality of these separate modules into one. And finally, you can even further generalize that all these programs belongs to the calculator application. So this is called as bottom up approach because we started from the bottom. We started from the separate functionalities. We merged them together based on their some general features and we come up with one general application. So here we can think of this top-down approach. Here is an example. This example is regarding designing a payroll processing system. So here the problem is broken down into the smaller units or called as modules and they are further broken down into even smaller units. Each unit will be called as a module and each module is a self-sufficient unit that has everything necessary to perform that particular task. So in this top-down approach, let's think about that. We have to design a payroll processing system. So you can think of some major task or some major functionality that a payroll processing system does. For example, getting the employee data into the system, then calculating the net pay, and then printing the pay slip. Now, to calculate the net pay, you may require further tasks like you may require calculate gross pay, calculating the deductions, and updating the employee record, maybe based on their attendance, etc. Then, while printing payslip, you may require data from different modules like get employee record, get the net pay of the details, and get the leave records. So here, if we are talking about top-down approach, we will first think of this in a broad that what is a payroll processing system needs to be. Then we'll think of the details that needed to be implemented. And even we can go further breaking down of those tasks. So this approach is called as the top-down approach. The next approach is bottom-up approach. In bottom-up approach, you first think of the specific functionality and then you go on adding those functionalities in some general modules and finally you come up with a complete system or an application. So here in this case, in this example, you can think of making a calculator as a system or as an application. So we may start with this particular functionalities like you may require a program which may calculate the square root or which may calculate the algorithmic value or which may perform this logical NOT operations which may perform comparison of two values etc or it may perform logical and it the other program may perform addition, the other program you may require for subtraction, the different programs you may require for multiplication, division, and all. So now think of that you have designed all these programs separately. Now you can combine these programs if they have something in common. So for example, these programs like addition, subtraction, multiplication, division can be summarized in the module like multiple input operation, so which requires multiple operands to perform this operation. You can perform this you can combine these two programs like comparison programming logical and of program in saying let's say two input operation. So that means here you require to perform this you require at least two inputs. So for comparison also you require two inputs so that you will be able to compare between the values. In case of logical and also if you want to perform ANDing of the values, you require at least two inputs. So you can categorize them at this level. That means this is what the generalization of these functionalities into general module. Similarly, we have generalized the functionality of these separate modules into one. And finally, you can even further generalize that all these programs belongs to the calculator application. So this is called as bottom up approach because we started from the bottom. We started from the separate functionalities. We merged them together based on their some general features and we come up with one general application. So this approach is called as bottom up. Thank you for watching C programming lecture series.